Hello, welcome. My name is Matthew Brady. I'm an associate professor in the section of endocrinology here at the University of Chicago. So I'd just like to talk a little bit about my training, my viewpoint on the training environment here at the section for fellows, and then a brief overview of the two projects ongoing in my lab. So I was an undergraduate at the University of Chicago, and then I stayed on to do my PhD at the University of Chicago. I'm not a total lifer. I went off to Ann Arbor for 6 years to work at a drug company, first as a postdoctoral fellow, and then I was promoted to senior scientist. And it was a really great time, really great training environment, no funding, no teaching, just experiments and papers and meetings. So it was great. But unfortunately, the company, Warner Lambert, which owned the drug company Park Davis, got bought out by Beagle and Pfizer. So just FYI, Lipitor is actually a Park Davis derived compound that Pfizer co-opted. Anyhow, I'm not bitter. So I came back to the university in 2001 into the section of endocrinology, diabetes, and metabolism, set up my lab, and I've been here ever since. In addition to being associate professor, I am also the chair of the PhD granting committee on molecular metabolism and nutrition, as well as the undergraduate director of the undergraduate specialization in endocrinology. So this kind of leads into what I think is unique about the training environment here is we are a clinical section. You will get excellent clinical training. I am a PhD, but I am fully aware of what fellows need to get out of their training. I've had numerous fellows come through my lab. But what I think is really unique here is that there's also a graduate program that is housed in the section of endocrinology. And again, I'm the chair of that program. Many of the faculty in this section are members of the committee, but the committee has faculty members, both clinical and basic science. So it really spans, what isn't metabolism. So it really spans the spectrum. The reason I bring this up is because I know bench research can sometimes seem like a daunting, impenetrable forest, but again, I've had many fellows come through my lab, and the great thing I think is in my lab we have endocrinology fellows and we also have graduate students. So I tell the fellows, if you want to get trained in bench science, you should have a graduate student help you. I haven't been at the bench for probably a decade at least. So it's a really nice mix of different types of training going on at the same time. And the other advantage is, and again, these are opportunities, these are not demands. If you're at all interested in teaching, there are plenty of teaching opportunities at the graduate and undergraduate level, if that at all interests you. If it doesn't, no problem. So I think that's something that really makes this training program unique. Again, you'll get the excellent clinical training that you'll hear from the other faculty members. But there are unique opportunities to conduct both clinical, translational, and bench research, as well as, if interested, getting some opportunities to get some teaching experience if that is something you want to check out. So my lab is based on the study of adipocyte biology in health and disease. We have two projects going on. One is more kind of straightforward. The other is a little more interesting, kind of off in a different direction. So the first one is looking at examining humans undergoing bariatric surgery. And so the surgeons here have been fantastic. They've been really collaborative, not just in terms of allowing us access to their patients and providing samples during surgery, but they've also looked at the grants and given ideas. So they're intellectually engaged as well. So that's been really great. Unfortunately, you won't have a tour here, but from my office, kitty corner across the street is the new medical center. That's where all the bariatric surgeries take place. And my lab manager has his own little cubicle with his scrubs, and he goes over to the suite and gets samples during surgery and then runs across the street and brings them back to the lab. So the basic idea is we're getting subcutaneous subcutaneous abdominal needle biopsies from these patients 2 weeks before surgery and then 12 weeks after surgery. We're interested in circadian rhythms. We're interested in insulin sensitivity. We're interested in changes in what the adipocytes are secreting. So I think this is a really great project for a fellow. Isabella Casimiro worked a bit on this project because you can, as a fellow, you can't do it all. But if you're interested in this project, what I tell the fellows is I'd like you to at least see everything. So everything from patient recruitment to the actual collection of the needle biopsies to the processing of the fat in the lab. And so you can get really kind of both patient interaction and then some translational research and some bench experience as well. So that's an ongoing project that we're starting to write up a bunch of papers, so that's good. The second project is a little more unique. I was in the old hospital, and there are these long corridors, and Dr. Suzanne Konzen, who's a clinical oncologist, kind of approached me. We had never talked before, but I knew who she was, and she said, "Hey, you're the fat PI." I was like, "Hey, now." That's the first thing she ever said to me. But what was interesting is she's working on a project with Dr. Martha McClintock, who's a biobehavioral psychologist. And what they're looking at is social isolation in rodents and the development of mammary gland tumors. And what Dr. McClintock first found in rats, Sprague-Dawley rats, is spontaneous model of mammary cancer, is that the female rodents, both rats and mice, like to be around other females. They like to sleep together, groom each other, eat together. But if you put one female rodent per cage, they're not able to handle the stress as well. The tumors develop more quickly, more aggressively. And so they're interested in trying to understand the molecular mechanisms behind these findings. The problem is with rats, it takes about 2 years to conduct an experiment. So it's very hard to get a postdoc or a graduate student interested in a project with that kind of timeline. So Dr. McClintock approached Dr. Konzen because she had a transgenic mouse model of mammary cancer, triple negative breast cancer in humans, which is a much more defined by 22 to 24 weeks. They all develop tumors because again, it's a transgenic model. So they repeated many of the experiments, found the exact same thing, that social isolation caused more aggressive tumors, larger tumors, more poorly differentiated tumors, which is a bad thing, in the mice. So what they then did is went back and did a microarray analysis around 15 weeks of age before the tumors had developed. And that's where they got this metabolic signature of enzymes that convert glucose to lipid. And that's why they needed a fat PI. So that's why they found me. And I have to give them credit. They're totally fearless, the two of them. If it's an area they know nothing about, it's like, well, we got to find someone who knows something about it. And so she approached me, and I was like, breast cancer? I was like, I know nothing about breast cancer. But I had a rotating graduate student. He was fantastic. So I wish I had slides to show you on this, but we did 2 experiments. The first, he showed that these gene changes, because when they did the microarray, they used the entire mammary gland, which is comprised both of adipose tissue, but also the ductal epithelial cells, for milk production, and it's these epithelial cells that give rise to the tumors themselves. So the question was, where are these metabolic gene expression changes occurring? So Paul was able to separate the ductal epithelial cells from the adipose, from the adipocytes, because the adipocytes literally float when you digest the mammary glands. And he found the changes were solely occurring in the adipocytes. So right away that caught my attention, because it meant that the effects of social isolation were not direct on the epithelial cells to promote the tumor genesis, but rather they were doing something in the adipocytes that was then being communicated to the tumors to cause this greater proliferation. So that was of interest. That was his first experiment. And then his second experiment was, he went on to show that these metabolic changes following social isolation were solely occurring in the mammary adipose tissue depot. It wasn't occurring in the subcutaneous, mesenteric, perirenal, perigonadal. He checked a whole bunch of other depots, and there were no changes in these metabolic genes. Now, there may be changes occurring in other pathways, but there was something unique about the mammary adipose tissue that was susceptible to this social isolation and this increased um, inability to dissipate stressors. So that was a project that we started in 2009 and is ongoing. And we recently, fortunately, just got the grant renewed. So if you would be interested in doing kind of the nexus between endocrinology and cancer biology, that might be an interesting project to think about as well. So those are the two main projects in the lab. If you end up coming here, I look forward to meeting each of you, obviously. But if you end up coming here, I'm happy to talk to you about any of these opportunities moving forward. So with that, I will stop, and I look forward to meeting you in the coming month. Take care.